Hello, welcome to our team presentation for Lab 2. My name is Phuc and my partner is Foad. For this lab, we decided, so the first part we do is define any useful function that's going to be used for data pre-processing. After that, we define the labels for our table in the data frame. And here, this code replace any missing value with the median for the number of columns. Here we do df.drop duplicates to remove any redundancy. And in this code, we normalize all numeric columns so that it's easier to process the numbers. And we ended up with this table right here. It only has 145,000 rows instead of 400,000. So we dropped down about 75%. After that, we label and code the outcome. So for the outcome right now is normal, and the normal are for normal attacks, or for the good connection, and anything that's not normal is considered bad connection. So anything that's normal will be turned into 0, and then anything that is a attack will be turned to 1. After that, we do one-hot encode all of the non-numeric column using pd.getDummies. And we ended up with a table with 119 columns. We drop 2 columns that are all null using this code right here. Okay. The first thing we do is try to build a fully connected neural network model. So in order to do that, we just go through the pretty much just building the basic layers. So we have the first layer, second layer, third layer, and we're just messing around with changing the activation and the functions. And that's for fully connected. And for CNN, one second. Okay, so for CNN, the first thing we do is we're going to have to reshape xtrain and xtest into this shape right here. CNN is used for processing images, so we're going to have to do some reshape for anything that is not images. And then we do np.array and then xtrain.type, all of that. And for this is the code where we build our CNN model. We just pass in the convolution 2D. We do a max pooling. We do another convolution, a layer, and then we do another max pooling, and then we flat it out, do a drop, and then at the end we do a dance with an output neuron, 2 output neurons together, and this is our results.
Yeah, as you can see, our confusion matrices come up pretty close to each other. The 2 models perform similarly. Our best CNN model ended up being Atom plus TANH at a kernel size of 1.1, 8 layers, and 1024 neuron count. It got us a 0.989 test accuracy. And our best fully connected was an activation of ReLU optimizer of Atom, 3 layers, and 10 neuron count. That one gave us a score of 0.977. So very close, but CNN just barely beats out fully connected in this case. And our task division and project reflection, we did it pretty collaboratively together. I worked a little bit more on the CNN. Phuc worked much more on the fully connected stuff and the confusion matrices. And our takeaway is that we should probably try to start it a little bit earlier so we have more time to experiment, but we couldn't this time because of midterms. And in terms of roadblocks, we had some trouble at the beginning to convert our data into like an image-like array until we added that extra dimension when reshaping. And our other minor roadblock was the outcome column wasn't being encoded properly, but we were able to get that fixed after some experimentation as well. And that's it.
Thank you for coming to our presentation.